Look at this image you're seeing right now. Is it real? Or is it a render? At first glance, it might seem obvious, but the longer you look at it, the more uncertain you become. Because today, we're talking about a tool that has almost completely erased the line between a real photograph and a computer-generated image. Its name is VRay. But here's the interesting part. What makes VRay important isn't just its stunning visual output. The story behind it might actually be even more fascinating. Because unlike what many people assume, this tool didn't start as a massive project or a team of hundreds of engineers. It began with a very simple idea. And in this video, we're going back to that starting point to see exactly how VRay evolved into one of the most essential rendering tools in the world today. Hi, I'm Hossein, and welcome to my YouTube channel. In this series of videos, we explore the stories behind the software that have become essential tools in our work today. In previous episodes, we looked at the origin story of 3ds Max and how it evolved into one of the foundations of the 3D world. And now it's time to move on to one of its most important companions, VRay. If you haven't watched that video yet, I'd actually recommend going back and checking it out later, because it will help you understand this story on a much deeper level. So let's start with a simple question. What was the world like before VRay? To understand what VRay actually changed, we need to step back for a moment and look at what rendering used to look like. If we go back to the 1990s and early 2000s, rendering was not what we know today. Yes, 3D images existed, but most of the time they only resembled reality, they were not reality itself. Usually when you looked at a render back then, you would notice things like lighting that felt artificial, shadows that didn't behave correctly, materials that looked flat and overly simple, and none of that natural feeling you expect from a real photograph. On top of that, the rendering process itself was far from easy. You could wait for hours, sometimes even days, just to get a single image. And in the end, when the render finally appeared, you would often find yourself thinking, okay, something still doesn't feel right. The problem wasn't that there were no tools. Software existed, and rendering engines were already around, but the issue was deeper than that. The real problem was that we still weren't truly simulating reality. Light in the real world behaves in a very complex way. It reflects, it scatters, it passes through different surfaces, and it's constantly changing. But what we were seeing in renders at that time was mostly just a simplified approximation of light, not the actual behavior of light itself. A crucial question started to emerge here. If we are simulating light with a computer, then why doesn't the result look real? On the surface, it sounds like a simple question, but this is exactly the point where everything starts to change, because answering it meant opening a completely new path in the world of rendering. The birth of chaos. In the late 1990s, while many companies were focused on improving existing tools, a small team in Bulgaria chose a different direction. It wasn't a large team, it didn't have a well-known name, and there was no massive funding behind it. But what it did have was a completely different way of thinking. That team would later become known as Chaos Group. The interesting part is that from the very beginning, their goal wasn't to build a big commercial product. They weren't sitting there thinking, let's create a rendering engine that beats everything else. Instead, they were working on a much more fundamental question. How does light actually behave in the real world? This question might sound simple, but the answer is anything but simple. Light doesn't just come from a source and hit a surface once. It reflects multiple times, it scatters, it loses energy, and with every interaction, it changes. And this is the key point that set this team on a completely different path. They weren't trying to build software from the beginning, they were trying to understand the physics of light. And this seemingly small difference would later become one of the biggest advantages of VRay. Where did the idea of VRay come from? Interestingly, the original idea wasn't complicated at all. In fact, it was the opposite. It was very simple. Instead of just approximating light and building a simplified version of it, why not make light behave exactly like it does in the real world? If we look at reality, light follows a simple yet highly complex path. It hits a surface, part of it reflects, part of it scatters, and part of it enters the environment and affects other surfaces. In other words, light doesn't just come from a source and reach our eyes directly. It bounces around the space multiple times, and it's exactly these interactions that create our perception of realism. The problem was that older rendering engines didn't fully account for this behavior. Most of them were working with a simplified model of light. Because of that, no matter how good the results looked, there was always something that felt unnatural. This is where VRay made a critical decision. Let's simulate this behavior as realistically as possible. Not as an approximation, but based on the same physical rules that exist in the real world. And this is exactly where concepts like global illumination and ray tracing were no longer just optional features, they became the core of rendering itself. In simple terms, VRay was shifting the approach from guessing how light behaves to actually calculating how light behaves. And that difference changed everything. Early versions. In the early 2000s, the first versions of VRay were released for Autodesk 3ds Max. At first glance, what immediately stood out was the output quality. It was genuinely different. Images had more depth, lighting felt more natural, and for the first time, renders started to feel closer to reality, not just similar to it. It was a real leap forward, but there was also a serious downside. Working with VRay was not easy at all. Unlike many tools at the time that tried to be simple and predictable, VRay required you to actually understand what you were doing. Because of that, many users, when they tried it for the first time, either felt overwhelmed or gave up very quickly. They expected it to behave like other render engines, but it didn't. The reason was clear. VRay wasn't just a simple tool with a few sliders and buttons. It was built on a real physical understanding of how light behaves. And if you didn't understand that logic, the settings didn't really make sense. And this is where an important shift happened. Even though many users gave up on it, there was a small group who kept going. They experimented, they made mistakes, and slowly they began to understand how this tool actually worked. And after some time, they reached an important realization. VRay wasn't just a renderer, it was a new way of thinking, a new way of understanding light, materials, and images. From this point on, the story is no longer just about a piece of software, it's about a shift in mindset. If you're enjoying the video so far, I'd really appreciate your support. Please like the video and subscribe to the channel, it really helps. If you want to go a step further, you can also support the channel through Super Thanks. And I'd love to hear about your experience with VRay. Share your thoughts, tips, or even any challenges you've had in the comments. Now let's move on to the next part of the story. Why did VRay succeed? The success of VRay was not accidental. It wasn't just luck, and it wasn't just timing. Several important factors came together that gradually turned it into one of the industry standards in rendering. First of all, output quality. For the first time, renders actually started to look like photographs. Not just from a distance, but even when you looked closely, they still held up. Lighting felt more natural, shadows behaved in a more logical way, and materials carried a stronger sense of realism. This was exactly what many people had been looking for years. Second, control. VRay gave users a high level of control. You could precisely decide how the light behaves, how materials react, and what kind of mood the scene would have. Of course, this control came with a cost. It took time to learn. But for anyone aiming for professional results, this wasn't a drawback at all. It was a real advantage. Third, balance between quality and time. One of the long-standing challenges in rendering was this trade-off, either high quality or reasonable render time. VRay managed to find a balance between these two, at least to a large extent. Compared to many rendering engines at the time, it delivered better results without making render times completely impractical. This is what made it truly usable in real production environments, not just for experiments or tests. And fourth, the user community. This might be one of the most important reasons behind its success. VRay quickly became popular among architects because it directly addressed what they needed most, a realistic representation of space before it is actually built. And when a tool becomes part of a professional workflow, it starts to grow on its own. More tutorials appear, more real projects are created with it, and gradually it becomes a standard in the industry. In reality, VRay wasn't just a good piece of software. It responded to the right need at the right time. And that's exactly what allowed its growth to never really stop. Entering architecture, this is the point where VRay truly started to scale. Until then, it was a powerful tool, but from here on, it became a necessity. Architects had always faced a fundamental problem. How can you communicate the idea in your mind before it is built in a way that others see it exactly the same? Plans and sections weren't enough. Sketches had their limits. What was needed was something that could make a space feel tangible before it existed. This is where VRay stepped in, because it delivered exactly what architecture needed: realistic lighting, believable materials, and spaces that felt alive. Gradually, VRay became part of the design process itself. It was no longer just for final presentations. It became a decision-making tool. Architects used it to test lighting conditions, compare materials, and even think about the emotional feel of a space. And from a certain point on, it was no longer just an option, it became a standard in many architecture studios. And maybe the most interesting part is this: a lot of the images we see today and assume are real photographs never actually existed in the real world. They were created with VRay. This is exactly where the boundary between reality and digital imagery starts to fade. Expansion. After its initial success, VRay was no longer limited to Autodesk 3ds Max. It gradually expanded into other software platforms: SketchUp, Rhino, Autodesk Maya, and this was a very important shift because it transformed VRay from a tool tied to a single software into an independent rendering engine that could exist across different workflows. In practice, wherever there was a 3D model, VRay could now be part of the process, and that meant its user base became larger and far more diverse. On the other hand, VRay itself also started to evolve. Faster versions were released, GPU rendering was introduced, and the engine began adapting to new demands, because by this point, quality alone was no longer enough. Competition. This is where things became more serious. Gradually, powerful competitors entered the field: Corona Renderer, Arnold Renderer, and later Unreal Engine. Each of them took a different approach. Some focused on simplicity, some on more physically accurate rendering, and others on speed and real-time output. And this led to an important shift. Quality alone was no longer the only deciding factor. Speed also became a critical requirement. Users no longer just wanted a single high-quality image. They wanted to reach results faster, to interact with the scene, and even see rendering in real time. And this is where VRay entered a new phase, a phase where it had to maintain its high level of quality while also adapting to a much faster world. A major shift. This is where VRay was forced to change. It could no longer remain what it used to be because the world around it had already changed. Speed had become important, interaction had become important, and user expectations had grown significantly. So VRay gradually evolved. New features were added, rendering methods were optimized, and it transformed from a relatively focused tool into a complete rendering system, a system that could adapt to different workflows and conditions. Today's VRay. Today, if we look at the industry, VRay is still one of the key standards in architecture, in VFX, and in large-scale professional projects. It is still widely used in many studios, and it remains a trusted tool for achieving high-quality results. But perhaps the more important point is this: VRay is not just software, it is part of a much bigger shift. A shift in how we perceive images, how we understand light, and how we reconstruct reality. If before VRay, rendering was closer to guessing, after it, it became much closer to simulating reality. And maybe that's exactly why, despite all the changes and competition, its name is still here today. If I want to put it simply, VRay didn't just improve rendering. Something deeper happened. It changed the way we look at reality itself. Before it, rendering was just a basic simulation, an image trying to look real. But after VRay, rendering became much closer to reality itself. Not just in appearance, but in the behavior of light, materials, and space. In fact, the issue was no longer just image quality, it was the way we think about image making that changed. Back to the beginning. Now, let's go back to the image you saw at the start of this video. Is it real or is it a render? Maybe in the past, that question mattered a lot, but now, maybe it doesn't matter that much anymore, because the boundary between the two is no longer clearly defined like it used to be. And this is exactly where the story of VRay comes full circle. And finally, if you're interested in this kind of storytelling, the stories behind software, and the tools that quietly shaped the way we work, this was just one of them, because almost every tool we use today has a story behind it, a story that usually stays invisible. If you enjoyed this video, you can also check out other episodes in this series, where we explore the origins of the most important software in design and architecture. And if you want, you can subscribe to the channel so you don't miss the next episodes. I'm Hossein, and here we talk about the tools that built the world of design behind the scenes. See you in the next video.